And this video is on probably our last, definitely our last video on DE applications. Okay, DE applications, and this one is on mixing problems. And everyone hates these, but they're not actually that bad. They're all the same as long as you get used to them. Okay, so mixing problems, and what these problems consist of. Usually, there's a tank. There's a tank, and there's some sort of pipe coming into the tank with some usually salt or sugar solution or something like that, or poison or something like that. It's going in. There's some water in here, into there, and it gets all mixed up in here. And there's some pipe coming out the end where there's water flowing out of there as well, or some solution of that. And usually, what you have to figure out is, what the concentration of that is, or how long something takes, or anything like that. But usually, you know what the concentration coming into there is, and you also know at what rate it's flowing. That's flowing into this. So some salt solution mixed in water. You know what the concentration is. You know what the rate is, and normally X or Q, can be Q, is how much salt is in the tank at some certain time, and you usually know what the volume of the tank is, like 200 litres or something like that is in there, and you're usually told what the rate is coming out, and you have to find the concentration and things like that. So that's the general problem, and I'll just flick over to this because I think this explains it the best. I made it, so of course I think it makes it best. But this is the basic setup of the problem, and I'm just going to talk through this. Okay, so I would always draw it like this. I would draw my tank, even if it's not really a tank question, but you can sort of show what's coming in. These are called difference of rates questions. You've got some stuff in here, okay, and you've got some stuff coming in. You've got this mixture coming in, and it gets mixed all around, and then you've got some mixture coming out, and the change of X. So if X is the amount of substance in there at the moment time, so the amount of salt or sugar or whatever, X is the amount of that substance in there, and V is the volume of the solution in the tank at time t. Your input rate, your rate coming in, is equal to your concentration of whatever you got in times by your volume rate going in. Your output rate is equal to the concentration going out multiplied by the volume rate going out. I'll come to this bit later. And so what the DE is, and the hardest bits of these questions is just setting up the DE. You can solve them easily, but the hard bit is setting them up. Is saying that the rate of change of X with respect to time is equal to the input rate minus the output rate. And that makes sense. The change of X is equal to however much comes in minus however much goes out. That just makes sense. The hard bit is sort of setting them up. But I'll just go to a question. So here we go. Let's actually go to a question. I'm not going to solve these. I'm just going to sort of show you how they're set up. Okay, so let's say we have a tank, and we've got, and this is how I always draw them. Okay, we've got stuff coming in and stuff going out. Let's say the volume initially in here is 200 litres. There's 200 litres of water in here, and let's say that Q is the grams of, let's say, salt, because they're always about salt. Q is the grams of salt mixed into here. And let's say that we've got a solution which is 5 grams per litre. That's the concentration, and it's coming in at 2 litres per minute. Okay, 5 grams per litre, that's the concentration. 2 litres per minute, that's the rate it's coming in. It's flowing in at 2 litres per minute. And let's say that it's flowing out at a rate of, I'll have to do this, 2 litres per minute. Okay, good. So let me just talk about this question again. firstly, we've got a tank. Initially it has 200 litres of water in there, and it's got Q grams of salt in there. That's how much grams of salt in there. That we don't know Q at this stage. There's a salt solution getting poured in, and it's 5 grams per litre. That's the concentration. That's how strong the salt solution is coming in, and it's coming in at 2 litres per minute. Fantastic. Then it's getting taken out of this tank after it gets mixed in and blah blah blah, and it's coming out at a rate of 2 litres per minute. And so what I want to do is set up this DE. So let's have a look at this. Now, going back to here, I'm going to keep referring back to this. We want to firstly find out what is my input rate. The input rate is equal to the concentration times by the volume. So this makes sense. If you look at this, it just makes sense. So what's the input rate? In other words, how fast is your grams of salt coming in? If you've got 5 grams per litre and they're coming in at 2 litres per minute, well, that's equal to 2 times 5 equals 10 grams per minute. Okay, 5 grams per litre, 2 litres per minute, that's 5 grams per minute. That's what's coming in that tube. So that's your input rate. Nice and easy. Now let's have a look at your output rate. What's going out? Back to here. Again, it's just the concentration times by the volume rate. Okay, so let's have a look at that. So it's the concentration. Which page is it? The concentration. What's the concentration of what's coming out? Well, we don't know. What it is, remember concentration, I just wrote it in here. Concentration is equal to the grams over, well, that's a bad way of saying it. I'll just take it, litres, I'll just put it like this, but that's bad. But what it is it's the mass over the volume. That's the concentration of anything, okay? Mass over volume. And so that's what we're trying to figure out here, okay? So what's the mass of the salt that's coming out? Well, that's Q. Okay, so that's the mass. What's the volume of the tank? Well, the volume starts at 200 litres. We've got 2 litres per minute coming in, and we've got 2 litres coming per out, so it's going to remain at 200 no matter what. It doesn't change. So it's Q over 200, and what we're doing is we're concentration times by the volume rate out. What is the volume rate going out? It's going out at 2 litres per minute, so that's times by 2. That's equal to Q over 100 grams per minute. Okay, so finally my DE, and this is the DE that we set up, is the change in Q with respect to time is equal to the input rate minus the output rate, and that's equal to 10 minus Q over 100, and that is your DE right there. Okay, so dQ dt is equal to 10 minus Q over 100, and that is your DE. So that's how to set it up. You can go and solve that, no problems from there on in. Okay, to solve that, you just put it over the same denominator, flip it upside down, and integrate. Okay, I'll just show you one different type. It's slightly different. So this one you can solve. The next one I'm going to show you cannot solve. You might say why? Well, it's still part of the course to be able to set it up, but not to be able to solve it. Okay. So I've got some. I'm just going to do almost I'll do almost exactly the same question. So we'll go 5 grams per litre. That's the concentration coming in at 2 litres per minute. Okay, it's coming in, and again, let's have Q. I'm just going to keep it all the same. 2 grams of salt. And initially we're going to have a volume of 200 litres. Coming out, it's going to come out at 3 litres per minute. Okay, so that's our situation there. Let's go. Let's have a look at what's going on here. And you'll notice the only difference between that is that we've got 2 litres per minute going in, 3 litres per minute out. And you can think about what's going to happen to the volume of this tank if this continues. It's going out faster than it's coming in. Alright, let's have a look at the input rate. The input rate is equal to the concentration times by the volume rate, so that's 5 times 2, that's 10. No worries. Output rate. Output rate is equal to the concentration of what's going out. Okay, what's the concentration of what's going out? Firstly, the mass of what's going out is Q. Q is going out, that's how many grams of salt is in the mixture, divided by the volume. Now what's the volume? Initially it's 200, but what's happening to the volume? Every minute it's losing 1 litre. So because 2 is coming in, 3 is going out. So every minute 1 litre is going out. So the way we'd write that is 200 minus T. Okay, so in other words, after 1 minute that'd be 200 minus 1. After 2 minutes that'd be 200 minus 2. The volume is dropping. So at time T, the concentration would be Q over 200 minus T. So that's the concentration, and that will be multiplied by the rate of it which is going out, so multiplied by 3. Does that clean up? Not really, so we'll just have 3Q over 200 minus T. And so therefore your dE will be dQ on dt is equal to your input rate, 10, minus your output rate, 3Q over 200 minus T. And that is your dE that you've set up from the mixing problem. Now the question I'm sure you're asking is, why can't we solve this? The reason we can't solve this is because you will solve it next year when you're at uni, but for now, what the problem with this is that we've shown you how to solve a dE of dy dx is equal to a function of x. We've shown you how to do dy by dx is equal to a function of y. That's no problems. But what you've got here is dy by dx equals a function of x and y. In other words, there's a q here and a t here, and we don't know how to solve this yet. This is something we can't do yet. So a question in an exam might ask you to set this up, but it will never ask you to solve this dE. We can't do that yet. We'll do it next year. So that's mixing problems, a bunch of fun. Thank you.